Okay, I'm discussing this out of level on the Viessmann boilers. It appears that tolerancing is not understood. So I'll try and explain this as best as I can, but a tolerance is when you state how level, flat, straight or dimensional a component that you're manufacturing or an installation that you're doing must be. So, for example, when I'm doing woodworking, such as making this door, if I make a component like one of these, if I'm within probably, I don't know, about 0.1, 0.2 of a millimetre, that would be really, really good. So, if I said, for instance, this part was going to be 200 millimetres long, and I could have it plus or minus 0.1 of a millimetre, then that would be my tolerance. My total tolerance would be 0.2 of a millimetre. Now that's all very well, but I'd need something that I could actually measure that with. Now, because I trained as an engineer originally on more of the imperial system than on the metric, I know that using a well-graduated, good quality stainless steel rule and an eyeglass, that I could measure quite accurately within 5/1000ths of an inch, which was a general tolerance that we're given for machining to. Usually plus or minus 5/1000ths of an inch would be a standard component tolerance. And regularly I would check my work with a rule and an eyeglass to be able to tell within those kind of dimensions. But quicker, back in the day, would have been a trusty micrometer. But even this equipment wasn't considered to be accurate. It was only accurate within a certain limit. So when we wanted to do really accurate work, we would use what were called gauge blocks. Now these were highly, highly precise to be within, fractions of a millimetre. And in fact, you can see here this metric set allows me to go down to 0.01 in increments. And even I have one in here somewhere which allows me to make a selection down as far as 5/1000ths of a millimetre. Now that is really, really accurate. But who tests these? Now this is not an inspection set, this is a general machine shop set. And these would be considered to be inaccurate. So even though it's down to those measurements, it's considered to be inaccurate compared to an inspection set. And an inspection set might be plus or minus 0.00, I'm going to make a number up because I don't actually know, 0.0001 of a millimetre, whereas this set might be expected to be accurate to 0.001 of a millimetre. Perfection cannot be achieved. It doesn't matter how hard we try, we will not get anything absolutely spot on. So we always have a tolerance stated for anything we're going to do where it matters. So, as I say, generally 5/1000ths of an inch, and I don't know what that is in metric. When I'm woodworking, I actually work with a set of calipers, and when I'm gauging thicknesses, I'll try and get in within probably about 0.2, 0.3 of a millimetre on a thickness. I know a bit of sanding and a bit of, jiggery pokery, a bit of whacking with a mallet will do the difference. So I'm not particularly bothered. But if I'm doing metal components and I want a shaft to go in a hole, and the shaft is 0.005 of a millimetre bigger than the hole I'm trying to push it in, it won't go in. But if it's 0.005 smaller than the hole, it'll go in. It'll be quite a tight fit, to be fair, but it will go in the hole. So these tiny, tiny differences can make a big difference depending on the application that you're working within. Now the same goes for general building work. And this is what we're given for general building work. Now there are even different grades of level. This isn't a particularly accurate one. It's not been machined on the face, and it's declared the accuracy or its tolerance is declared on the level. So on here it says somewhere, I took a picture of it yesterday so I know it's here. Oh, maybe it's not on this. Oh yes, here we go. So on here it says 0.5 of a millimetre per metre. Now that's the accuracy of the level. So what it's saying there is basically, it could be as much as 0.5 millimetre out over the length of 1 metre on this rule, and they would consider that to be accurate. So this level is not accurate, or is it? Just depends on the application you're working to. Now I would say over a metre, 0.5 of a millimetre if I'm building a wall or erecting a partition wall would be very, very accurate. But how do I measure it? I've only got some guidance on here. I have to make a judgment of where this lies, and even slight movements of this will have quite a big effect on this bubble. And in fact, I checked this a little bit earlier. This shim here is 3 millimetres thick. If I place it under one end of this level, my bubble is right on the edge of my line. So basically I've got plus or minus 3 millimetres over a length, and this is a 1.2 millimetre spirit level, of accuracy between those points. Now, I've been around here checking a few items here around the place, and generally most things around the place are within that bubble. And I would say that's pretty good. If I was on a floor that was that level, I would be happy. My bench here, look, it's reasonably within that. I wouldn't mind betting if I go around here, I'll find a few of these walls aren't that level. And what about these big beams up here? Now, I doubt very much whether they've actually managed to get those within this accuracy. Hopefully they have, but you know, they're heavy and they're propped up on brick and they've probably settled a bit. So, you know, if you're setting something like a beam in, you would set a tolerance and you would say, right, well, I'll accept that over the length of that beam, we could be out, let's say, 1 centimetre. Now, that might be quite reasonable just for a floor beam. But, you know, something else that's going to be far, far too big. So tolerancing is really, really vital. In fact, when I worked as an engineer in the factory, a lot of people were struggling with the concept, and we used to make an optical slide where 2 metal components were mounted at each other at right angles. And what we had to do was there was a tolerance for squareness for these things to mount. So what we did in the fitting department was we put little pieces of plastic shim under an edge and tightened them up with a screw, and then measured the angle until we got it right. Now, this seemed really stupid to me, so one of my jobs there was to do the layouts and the production procedures. So what I did was I said, well, okay, what we do is we'll machine this in the workshop already square within the tolerance. So then all we do is take the second component on and bolt it straight on, and it will be square within tolerance straight away. The fitters won't spend hours shimming it up with bits of plastic. And quite a few people objected to this idea, saying it would add an extra 30 seconds to the machining process on this face. But compare that to the 5, 10, 15, 20 minutes it might take to put shims under here. It was a nonsense. I won the argument. We made a new jig. We set it up. We machined this face square within the tolerance, and the parts just assembled. So instead of a fitting job, we now had an assembly job. And hopefully that's enough information to spread the message.